Students, in the last class, we have already started the center of mass, the concept of the center of mass, and we have done problems on that also. So we will continue with the same. Right on, students. Next, velocity of center of mass. Side heading लिखिए बेटा. Velocity of center of mass. Velocity of center of mass. Velocity of center of mass. Pay attention. What is this velocity of center of mass, students? यहाँ पे हम देखेंगे बेटा velocity of center of mass क्या होता है. What is the velocity of center of mass? Yesterday we have seen the positions of the center of mass. Suppose like here also, if suppose like we are having one particle of mass m1, it is moving with velocity, some velocity v1. Another particle is there of mass m2, it is moving with the velocity v2. Mass m2 moving with the velocity what? v2. Now students, where is the center of mass of these two particles? 100% along the line joining as well as in between. Not I don't say exactly at the center, because we don't know whether the masses are equal or not. So therefore what I say is the center of mass, where it will be lying? In between these two. So that center of mass will also be moving. Try to understand my question. This m1 is moving with the velocity v1, m2 is moving with the velocity v2. m1 is moving with the velocity v1, m2 is moving with the velocity v2. Okay, so this is m1 and this is m2. I hope it is clear. Now where is the center of mass? Center of mass will be somewhat here. So when these two masses are moving, along with that center of mass also will be moving. So that velocity we are calculating. What is the velocity of the center of mass? So pay attention, it's very simple. Yesterday we have seen, students, position of the center of mass like xcm. What is that? m1 x1 m2 x2 by m1 plus m2 by m1 plus m2. Now what I do, I just cross multiplied बेटा. अच्छे से देखिए अब आप क्या कर रहा हूं मैं. m1 plus m2 into xcm, that is equal to m1 x1 plus m2 x2. Just I have cross multiplied. Now this I am differentiating with respect to time. That means I need to have the small change in position for a small time. That means we can consider the differentiation part dx by dt. So if I differentiate this, what I am going to get, let us see. अगर मैं इसको differentiate करता हूं तो क्या मिल रहा है बेटा, जरा अच्छे से देखिए. This is constant, I can keep as it is, m1 plus m2. This is xcm differentiation. So this is what? dxcm by dt. I am differentiating this with respect to time, and I am not differentiating masses. By because the masses are constants and they are attached constants. So therefore we have to keep that as it is. Next beta, यहाँ पे देखिए आप. This is what? m1. This is dx1 by dt plus m2 dx2 by dt. What I have done, I have just differentiated. No need to worry. This is x dx by dt, x1 dx1 by dt, x2 dx by dt, dx2 by dt. I am not differentiating masses. The reason here masses are the attached constants. They cannot be zero. We have to keep as it is. Now, m1 plus m2 as it is. m1 plus m2. Now, I need the answer for this. What I can write? dx by dt की जगह पे क्या लिख सकते, थोड़ा जल्दी भी जाइए. What we can write in place of that? Please fast. In place of dx by dt, just dx by dt. Yes, very good. dx by dt is very good beta. Dx by dt is nothing but the velocity. So therefore what I do here is, since this is dx cm by dt, that means it is the velocity of the center of mass. So therefore this is the velocity of the center of mass, that is equal to, this is m1. Now see, dx1 by dt, so this is the velocity of the first particle. So therefore I'll write v1 plus m2 v2, m2 v2. Now beta, what is the velocity of the center of mass we are getting? देखिए यहाँ पे हम दो चीजें कर रहे हैं, two parts I am showing you. What are the two parts? सबसे पहले तो ये देखिए अब आप, this is m1 plus m2 into this. अच्छा एक मिनट, यहीं से मैं डिवाइड करता हूं. व्हाट आई वाज सेइंग, टू पार्ट्स नो, यहां पे हम डिवाइड कर देंगे. व्हाट डू यू से बेटा, व्हाट डू यू से अबाउट mass into velocity? I want to divide here itself. So mass into velocity, you know, mass into velocity is momentum. Mass into velocity is momentum. So therefore what I do, you know, इसको मैं क्या कर रहा हूं, अच्छे से देखिए. The first one, mass into velocity, this is the total mass into velocity of the center of mass. So therefore we can say this is PCM. Momentum of the center of mass, we can write momentum of the center of mass. Next, what do you say about this m1 v1? It is the momentum of the first particle, plus what is this momentum of the second particle? So we can write momentum of the center of mass is the sum of the momentums. पूरों को हम क्या करेंगे, sum of the momentums करेंगे. In vector forms if you want to write, you can write just bar over it. तो यहाँ पे ये first part. Second part बेटा, they can ask you what is the velocity of the center of mass. So velocity of the center of mass is equal to, this can be written as m1 v1 plus m2 v2 by m1 plus m2. कॉपी कर लीजिए फास्ट. हेलो, बेटा one of the student has sent out, what is this? This is the momentum बेटा, ये momentum है. Momentum is mass into velocity. So this is mass into velocity. I have written PCM, momentum of the center of mass. This is again mass into velocity, that is P1. M2 V2, that is mass into velocity, that I have written as P2. ठीक है. Now question add-on. Question: two particles of masses 1 kg and 2 kg. Two particles of masses 1 kg and 2 kg of masses 1 kg and 2 kg are moving along the same line. Are moving along the same line. with speeds 2 meters per second and 4 meters per second. 2 meters per second and with speeds 2 meters per second and 4 meters per second respectively. 4 meters per second respectively. Calculate the speed of the center of mass of the system. Calculate the speed of the center of mass of the system. Calculate the speed of the center of mass of the system if if both the particles are moving in the same direction. उसको पिन करें मैडम. थैंक यू जज़ाकल्लाह. If both the particles are moving in the same direction, calculate the speed of the center of mass of the system if both the particles are moving in the same direction. If both the particles are moving in the same direction. Now pay attention. M1, I'll write the data first. M1 is 1 kg. You can see clearly. M2 is 2 kg. What is V1? V1 is 2 meters per second. And V2 is 4 meters per second because they are moving in the same direction. So therefore, this is plus, this is also plus. If suppose they are moving in the opposite direction, we have to take it as 1 plus other minus. Okay? चलिए लिखिए बेटा. What is the formula to calculate the velocity of the center of mass? VCM is M1 V1 plus M2 V2 by M1 plus M2. So what is this M1 V1? M1 is 1, V1 is 2. Plus, what is M2? M2 is 2. V2 is 4. Divided by M1 plus M2. What is this M1 plus M2? 1 plus 2. So that is equal to, this is 2. Plus beta देखिए यहाँ पे ये how much this is 8 by 3. So this we can write it as 10 by 3 or you can divide also. So this is the answer. 10 by 3 meter per second. चलिए बेटा नेक्स्ट क्वेश्चन. Two particles of equal masses. Next question. Two particles of equal masses are moving along the same straight line. Two particles of equal masses are moving along the same straight line with the same speed. With the same speed in opposite direction. Two particles of equal masses are moving along the same straight line with the same speed in opposite direction. In opposite direction. In opposite direction. What is the speed of the center of mass of the system? What is the speed of the center of mass of the system? What is the speed of the center of mass of the system? I'm giving 1 minute time beta, solve this, because this model, I think you have understood this. So think for this and tell me the answer. I'm giving 1 minute time. After that, I'll solve it. Only in one group I'm receiving the answers beta. What about the other group? Chali. Okay, I'll show you. The two particles are there of same masses. Same masses. So what I do, you know, बेटे अच्छे से देखिए, of same masses m as well as m. Now what they are moving with equal speeds. This is v, this is also v, but they are moving in opposite direction, that is mentioned in the question. So therefore one is v, other is minus v. So just substitute in this. Here you have taken already minus, no, यहाँ पे लेने की जरूरत नहीं है बेटा आपको. You need not to take here minus, already you have taken minus here. So m1 is m, v1 is v, minus m2 is m, v2 is v, by m plus m. So therefore what we can do here is mv minus mv by 2m. So this to get cancelled, 0 by 2m. So answer is what? 0. That is 0 meters per second. That means the center of mass is at rest. No doubt the particles are moving in the opposite direction. We agree. But the center of mass is remaining at rest because its velocity is 0. Okay? Next question is, students, two particles A and B, capital A and capital B. Two particles, capital A and capital B, initially at rest. Initially at rest. Initially at rest, move towards each other. Move towards each other under a mutual force of attraction. Under a mutual force of attraction. Full stop. At the instant when the velocity of A is v, at the instant when the velocity of A is v, beta ye easy questions nahi hai. One of the student asked, sir, will this type of questions can be asked in? Yes, definitely. Aap mistakes kahan pe kar sakte hain? I can show you. Maximum students do mistake here. Only in one group, beta, I received 0. And I don't know why only in one group all 0 0 0 0. But when I see the other group, no answer from the other group. So the questions can be asked like this. Also, don't expect the question paper to be tough. There is a strategy to have the question paper. Some questions will be easy, very easy for you. Some questions will be average and some questions will be above average. We don't expect in any question paper of any exam, don't expect all the questions to be below average. Don't expect all the questions to be above average. So we examiners have certain rules to make the question paper. Some questions has to be below average in the sense, if suppose you are studying something, you must be in the position to do that. Some questions will be average and some questions will be above average. Above average means standard questions, tough questions, to know up to what level you have studied. ठीक है बेटा, चलिए. The question was, two particles capital A and capital B initially at rest move towards each other under a mutual force of attraction. Under a mutual force of attraction. Full stop. At the instant when the velocity of A is v. At the instant when the velocity of A is v, capital A is v, and that of B is 2v, and that of B, capital B, is 2v, The velocity of the center of mass of the system. The velocity of the center of mass of the system. The velocity of the center of mass of the system. बेटा यहाँ पे एक न्यू वर्ड देखे आप, म्यूचुअल फोर्स ऑफ अट्रैक्शन. अंडरलाइन दैट वर्ड. कंप्लीट वर्ड्स को आप अंडरलाइन करिए. म्यूचुअल फोर्स ऑफ अट्रैक्शन. First try to understand what is this mutual force of attraction, then we will come to the question. ठीक है, यहाँ पे देखिए बेटा, to understand, to make you understand in a more clear way, I am giving one example. देखिए यहाँ पे, if I take one magnet I am taking, this is the south pole, this is the north pole. Another magnet also I am taking with what you call the north pole and the south pole. So what do you say? What do you say? 100% there is a force of attraction. ये force of attraction होगा बेटा, ये इस तरह से, ये इधर आएगा बेटा और ये इधर आएगा. So मेरा सवाल आपसे ये है, my question with you is, are we applying any force to move these magnets? Are we applying some force to move this magnet? No. No, we are not applying any force. By themselves they are getting attracted. By themselves they are getting attracted. So therefore they are getting attracted by their mutual force. उन खुद के force से they are getting attracted. So therefore what I say, you know, it is the mutual force of attraction. We are not applying any force. We are not applying any external force to make them to move towards each other. By themselves, mutually they are moving towards each other by the force of attraction. So therefore this type of attraction we are calling it as mutual force of attraction. I hope it is clear. Now अब आएंगे बेटा हम, this is the example for understanding I have given. Now क्या होगा बेटा यहाँ पे, अब next our question, हमारे question पे आ जाइए बाप. Two particles are there, two particles of masses, what they have mentioned, they have not mentioned the masses, but the velocities they have mentioned. One is v, other is 2v. Masses they have not mentioned. So one particle is there, but suppose the mass, this is the A, this is the particle A, this is the particle B, particle A and particle B, this is the particle B. Okay, particle A and particle B. So what I do, you know, the mass of this is m1 and the mass of this is m2. It's clearly mentioned in the question, they are moving under mutual force of attraction. देखिए attraction हो रहा है और mutual force of attraction हो रहा है. So attraction means I have to give the directions like this. Is it right? So this is moving with the velocity v, this is moving with the velocity 2v. It's clearly mentioned बेटा, वहां पे देख लीजिए आप, क्वेश्चन में खुद देखिए, I am reading the line. At the instant the velocity of A is v and the velocity of D is 2v. So इसका जब velocity v है, इसका velocity 2v है. What is the velocity of the center of mass? तो बेटे यहाँ पे to calculate the velocity of the center of mass, what I do, you know, I use this equation. VCM is what? m1 v1 plus m2 v2 by m1 plus m2. So from this data, it's clear that v1 is v, v2 is 2v, but with negative sign. Why negative sign? It is not mentioned, no. यहाँ पे तो कहीं पे भी आपको दूर दूर तक अगर आप देखेंगे क्वेश्चन में, तो आपको कहीं पे भी आपको नजर नहीं आ रहा, यू आर नॉट एबल टू गेट द डेटा दैट दे आर मूविंग इन द ऑपोजिट डायरेक्शन. The word opposite is not mentioned, opposite direction is not mentioned, but instead of mentioning that, they have mentioned the mutual force of attraction. So whenever the attraction is there, no beta, attraction hota hai, to what happens, you know, they will move in the opposite direction only, like this. They are moving in the opposite direction. So this is I am taking as v, and this I am taking it as minus 2v. Okay, I can substitute here, but one data still it is missing. और कुछ data miss हो रहा है बेटा, m1 and m2 क्या है, so that we can substitute there. So for that what I do, mutual force of attraction means I have shown you one, एक तो हो गया they are moving in opposite direction, दूसरा क्या होता है बेटा, दोनों के forces बराबर होते हैं. दोनों के फोर्सेस बराबर होता है। क्या मतलब है बेटा? द थिंग हियर इज हाउ मच फोर्स दिस ए exert on B exert the same force on A. Try to understand my wording. Suppose this A is exerting a force, मतलब कितने फोर्स से खींच रहा है बेटा? 2 न्यूटन से खींच रहा है B को, तो B भी क्या करेगा? A को अपने तरफ 2 न्यूटन से खींचेगा। So that is the meaning of mutual force of attraction. I hope it is clear. Meaning समझ में आ रहा? Mutual force of attraction मतलब how much force A exert on B, the same force will be exerted by B on A. This is one thing. Attraction है, इसलिए they are moving towards each other. So what I do, देखिए दोनों के forces बराबर है बेटा। FA is equal to FB. I hope it is clear. दोनों के forces बराबर है। So therefore, what I do, students, this can be written as M1 A1 is equals to M2 A2. Force F is equals to Ma, Newton's second law. Now this is M1 as it is, beta. Ye M1. What is this A1? A1 is what? Acceleration. Acceleration is change in velocity by time. You know this formula. Acceleration is change in velocity by time. Change in velocity, थोड़ा सा बड़ा लिखता हूं मैं यहाँ पे, v minus u by t. Acceleration in change in velocity by time. But as per the question, initial velocity is 0. They are starting from rest. They are starting from rest. मतलब बेटा ये पार्ट क्या हो गया? 0 हो गया, तो acceleration is equals to velocity by time. Can we write acceleration as velocity by time? चलिए लिखते हैं. This is a1. A1 is velocity by time. What is this velocity? V by t. That is equals to m2 as it is, beta. What is a2? Again it is acceleration by time. So acceleration is what? Velocity by time. So therefore velocity is how much? 2v by t. Now this v get cancelled, this t get cancelled. So m1 is equal to, I can say it is 2m2. I got one relation between m1 and m2, that is m1 is equals to 2m2. I hope it is clear. m1 का जो मास रहेगा ना बेटा 2m2 के बराबर रहेगा वो। अब हम सब्स्टिट्यूट करते हैं, आइए। What is this m1? m1 is 2m2. Just now अभी हम देखें, this is m1. I am replacing m1 by 2m2. What is v1? v1 is v plus m2 is m2 only. What is v2? v2 is minus 2v. m plus m1, that is m1 is 2m2 plus m2, that is equals to, तो ये कितना हो रहा है देखिए बेटा, 2 m2v minus 2 m2v by 3m2. Now what is 2m2? v minus 2m2v beta. ये देखिए, this part and this part get cancelled. It is 0. 0 by 3m2, some 0 by something is 0. That means the velocity of the center of mass under this situation again is 0. That means the velocity of the center of mass is at rest. Copy कर लीजिए. The center of mass is at rest. beta this part is acceleration. Acceleration is change in velocity by time the particles are starting from rest, so therefore initial velocity is 0. ठीक है, तो ये this is v by t as it is. ये तो हमारा जनरल मेथड है, ये नहीं भी बताता तो you must be in the position now to imagine this part, लेकिन but still I am showing you this part. ये just हमारा क्या बोलना चाहिए, बेसिक पार्ट है बेटा ये, ठीक है. now this is fa is equal to fb, दोनों फोर्सेस बराबर है. फोर्स इज नथिंग बट एक्सेलरेशंस. f is equal to ma, f is equal to mv. तो यहाँ पे हम लिख रहे हैं बेटा m1 a1, यहाँ पे लिखते हैं m2 a2. what is acceleration? Velocity by time. what is acceleration? Velocity by time, but here velocity is 2v, no, so that's why I'm taking 2v. तो ये v और ये v कैंसिल हो गया बेटा, ये t and t get cancelled, so therefore m1 is equals to this is 2 into m2, that is 2m2. I hope it is clear. Why we are not taking here minus 2v? आपको one of the student has sent a question, why we are not taken here minus 2v. देखिए बेटा यहाँ पे just we are considering the magnitude of the velocity, ठीक है. here directions we are not considering, actually directions कब consider करेंगे आप, वहां पे consider करेंगे. here just we are finding the relations. अगर आपका सवाल के हिसाब से आगे बढ़ा, if suppose I move as per your question, तो क्या होगा देखिए. I hope you everyone has written right. तो आप देखिए आपके हिसाब से बेटा मैं यहाँ पे माइनस लिख दिया बाई मिस्टेक आप भी लिख दिए माइनस, तो आंसर क्या आएगा मालूम है, माइनस आएगा. m1 इज इक्वल्स टू माइनस 2m2. अब मेरा सवाल आपसे ये है, माय क्वेश्चन इज टेल मी कैन द मास बी नेगेटिव. यू कैन से मास इज 1 kg, 2 kg, 3 kg. Can you say mass is minus 1 kg? How much your mass is means will you say that it is minus 40 kg, minus 50 kg? Masses, they are the scalar quantities. So to consider the scalar quantities, we don't consider any directions. Directions हम नहीं देखते बेटा. Vector quantities के लिए we have to take care about the direction. Since we are calculating the velocity, velocity is the vector quantity. Our aim is to calculate the velocity. Velocity is the vector quantity. So therefore, we are considering the directions plus v minus 2v, everything we are considering. But our aim is to calculate the relation between the masses, right? Masses are the scalar quantities. So we did not to consider the directions here. I hope it is clear. समझ में आ गया ना बेटा? The one who asked the doubt. 633. चलिए बेटा नेक्स्ट साइड हेडिंग बनाइए. नेक्स्ट साइड हेडिंग acceleration of the center of mass. See, we have seen about the velocities of the center of mass, right? Now the question is acceleration of the center of mass. Acceleration of the center of mass. Now, what is this acceleration of the center of mass? Chaliye. You know what is acceleration? Just now I said you, it is the change in velocity with respect to time. That is the acceleration. Rate of change of velocity with respect to time, that is called as the acceleration. Now, acceleration, we are calculating the acceleration of the center of mass. Let us go with how to move. देखिए बेटा, just now we have derived this relation, right? VCM is m1 v1 plus m2 v2 by m1 plus m2, m1 v1 plus m2 v2 by m1 plus m2. बेटा यहाँ पे देखिए आप, what I am doing, just now we have derived the center of mass of the velocity of the center of mass. Just now we have derived, no, at the starting. बेटा एक बार पढ़ लीजिए, I am giving 1 minute time because that is completely same as this one. ठीक है, जल्दी fast. Will read only the topic velocity of the center of mass. आई होप यू हैव रेड इट। अब देखिए बेटा, मैं उस वही चीज यहाँ पे अप्लाई कर रहा हूँ। दिस इज द वेलोसिटी आई हैव टेकन m1v1 प्लस m2v2 बाई m1 प्लस m2। सो व्हाट आई एम डूइंग बेटा, क्रॉस मल्टीप्लाई करेंगे इसको। आई क्रॉस मल्टीप्लाई दिस, सो देयरफॉर m1 प्लस m2 into vcm, आई एम selecting the same method to derive, ठीक है, for the derivation purpose. So this is m1 plus m2 into vcm, that is equals to m1v1 plus m2v2. Now what we are doing beta, we are differentiating this with respect to time again. So therefore m1 plus m2, these are the attached constants. So therefore this we can write it as vcm dvcm by dt, that is equals to m1 dv1 by dt plus m2 dv2 by dt. I hope it is clear, ठीक है। Now आइए बेटे, attention, pay attention. So this is m1 plus m2 as it is, m1 plus m2. What is this part? Velocity by time. Is it not acceleration? Rate of change of velocity is acceleration, and the two instantaneous acceleration we are considering. So this, in place of this part, I am going to write acm. acm, that is equal to this, we can write it as, this is what, again this is acceleration dv by dt, this is also acceleration dv by dt. So therefore I will write m1 a1 plus m2 a2, ठीक है ना बेटा। अब यहाँ पे देखिए आप, what is acm, this is acm, that is acceleration of the center of mass is m1 a1 plus m2 a2 by m1 plus m2, m1 plus m2, this I am taking in the denominator. But the same thing again, if I bifurcate this concept, this line, I am getting one thing a as the acceleration. This is एक तो acceleration मिल गया बेटा, this is acceleration is equals to ये नीचे चलेगा। Next, what do you say about mass into acceleration? Mass into acceleration, mass into acceleration, can I say the force? F is equals to ma. So therefore, yes, we can say, so therefore what we can do here is force as the product of mass and acceleration. तो यहाँ पे हम substitute करेंगे बेटा, force on the center of mass is equal to sum of the forces, that is F1 plus F2. In vector form, if you want to write, you can write in vector form also. What we have to write in vector form? Just हमारे को बार देना है बेटा, आपको पता है। This is the vector form. So in previous also beta, velocity we have done, no, there we have done momentum. Momentum p is equal to, पहले वाले concept बता रहा हूँ, p is equals to p1 plus p2 we have written, no. In vector form there also you add, in vector form p bar is equals to p1 bar plus p2 bar, previous में add करिए, not here. This is the concept you have to copy. Now Characteristics of center of mass. Characteristics of center of mass. Characteristics of center of mass. First point. Characteristics, we are saying the properties of the center of mass. We are saying all the properties are important for your, what you can say, competitive level. Any property can be asked as a theoretical question beta. First point banaiye. First one, मैटर में, फर्स्ट पॉइंट बनाना है आपको. फर्स्ट कैरेक्टरिस्टिक, मैटर may or may not exist at the center of mass. First property is matter may or may not exist at the center of mass. Matter may or may not exist at the center of mass. This point I have already explained when I was explaining the center of mass, concept of the center of mass. So matter may or may not exist at the center of mass का मतलब क्या है बेटा, यहाँ पे अच्छे से देखिए आप. If you consider a ring, not the circular plate. Circular plate पे I have given you this example, I think. So circular plate पे you are having the mass at the center of mass. But for a ring, what do you say? Example, यहाँ पे मैं examples देता हूँ इसके लिए. For a ring, we have the center of mass at the center, but no mass there. We don't have any mass at the center of mass. Example बेटा, यहाँ पे example हम बनाएंगे. Example 1, first characteristic के लिए example 1. So ring, this is the ring, center of mass will be here. This is the center of mass, और ब्रैकेट में लिखना है आपको नो मास. यहाँ पे मास ही नहीं है बेटा. सेंटर ऑफ मास तो सेंटर पे है, बट वी डोंट हैव एनी मास. सो मैटर मे और मे नॉट एग्जिस्ट, मे एग्जिस्ट और मे नॉट एग्जिस्ट. अब मे एग्जिस्ट का एग्जांपल आप कहाँ पे देंगे, कहाँ पे देंगे बताइए. ये देखिए नो मास. अगर मैं यही चीज सर्कुलर प्लेट लेता हूं बेटा, सर्कुलर प्लेट, वेयर इज द सेंटर ऑफ मास, दिस इज द प्लेट. सो व्हाट वी डू, वी फिल्ड अप विद दिस मटेरियल. ठीक है, प्लेट है ये इस तरह से. सो यहां पे रहेगा. तो दिस इज द सेंटर ऑफ मास, बट ब्रैकेट में लिखना मास. यहाँ पे प्रेजेंट है, मास प्रेजेंट है बेटा. यहाँ पे सेंटर ऑफ मास पे देयर इज नो मास. दिस इज द फर्स्ट एग्जांपल व्हाट आई एम गिविंग. अनदर एग्जांपल व्हाट यू कैन गिव इज, one example you can give, another example, hollow sphere and the solid sphere. For solid sphere, we have, solid sphere means inside the material will be there, that means mass is there. But for a hollow sphere we don't have mass, right? अब second example मैं लेता हूं यहाँ पे hollow sphere. hollow sphere, this is the hollow sphere. sphere के लिए थोड़ा सा हम इस तरह से बनाएंगे बेटा lining, so that it is understandable. this is a sphere. ठीक है. So this is the sphere. Where is the center of mass? Center of mass is here at the center. This is the center of mass, but here we don't have any mass. So it's not necessary that always mass must be present at the center of mass. So matter may or may not exist at the center of mass. Copy कर लीजिए. नेक्स्ट कैरेक्टरिस्टिक बनाइए बेटा, नेक्स्ट कैरेक्टरिस्टिक, if no external force, if no external force acts on the system, if no external force if no external force acts on the system, the center of mass of the system the center of mass of the system may be at rest, may be at rest or moving with, may be at rest or moving with uniform velocity, may be at rest or moving with uniform velocity, may be at rest or moving with uniform velocity. But I hope you have understood the point what I have given you. If there is no external force acting, कोई force act नहीं हो रहा है बेटा external force center of mass पर. So therefore, the center of mass, if the body, if the system is at rest, it will be at rest only. It will be motion. It will be in the motion itself. That the what we have studied about the Newton first law. उसी को concept हम यहाँ पे recall कर रहे हैं बेटा. If there is no external force acting on the system, then the center of mass of the system may be at rest, या may be moving with the constant speed या constant velocity. ठीक है, third point बनाइए. Internal forces, third point, internal forces do not change the position. Internal forces do not change the forces, the internal forces do not change the position, do not change the position, do not change the position and motion of the center of mass. See beta, what do you mean by this? Internal forces do not change the position or the motion of the center of mass. सबसे पहले I'm giving an example of the center of mass for the position. Try to understand what is this point is. Example 1. Suppose we are having a cracker here. One cracker is there. यहाँ पे एक cracker है बेटा. This is the cracker. So when this cracker explodes, you know, when this cracker explodes, the cracker is at rest. Try to understand my wordings. Cracker is at rest. And after few seconds, it is exploding. ये explode हुआ cracker. तो बेटा different particles, ये कैसा होगा जरा अच्छे से देखिए आप. For this cracker, different particles जो भी रहेंगे ना बेटा, different particles of this cracker, they will be moving in different directions. इस तरह से move हो जाएगा, इस तरह से different directions में पूरे cracker के particles they are going to move in different directions. But after that explosion, if you go and check the position where you kept the cracker, some mass will be there. Some mass of that cracker will be, you are going to observe 100%. Some mass of that cracker will be lying at that place only. So what is that mass? That mass is the center of mass. That was not disturbed by the internal force. ये जो explode हुआ ना बेटा cracker, it is exploded because of the internal force, right? Because of the internal force, it has been exploded. So therefore, what I say here is, if you, after explosion, if you go and check the place where you kept the cracker, so 100% some traces of that cracker will be there. What is that traces? The traces, it's nothing but the center of mass of that cracker, which was remaining unaffected by the internal force, that is explosion. तो ये यहाँ पे different particles will be moving in different directions. लेकिन बेटे ये एक चीज याद रख लीजिए आप, इसका center of mass यहीं पे रहेगा. This is not going to move. That means rest पे है तो rest पे रहेगा. It is not going to move with the effect of internal forces. Internal forces do not affect the position of the center of mass. This is the situation. Next example, position. This is for the position I am saying. This position is not changing. Let us say the motion. अब हम motion की बात करते हैं. Example 2 में यहाँ पे I'll write for your understanding. Position does not change by internal forces. Next. Second example I am giving, motion also. Motion does not change. Acha, better if I write this wording, position of center of mass. Thoda sa add karna beta. Position of center of mass does not change by internal forces. Yahan pe bhi hum likhenge motion of center of mass does not change by center of mass, by internal forces. We are speaking about internal forces, right? So yahan pe aaiye. So motion of the center of mass does not change by internal force. Motion भी change नहीं होने वाला है बेटा. Motion change नहीं होना है मतलब जैसा motion था बस वैसे ही motion रहेगा. किसका? Center of mass का. It is the best example what I am giving you to make you understand in the clear way. देखिए अच्छे से बेटा. Suppose this is a target. That is a target, and from a cannon, from one cannon, this is the cannon, and from the cannon we are firing one shell to destroy that target. Shell, it is like an explosive material to destroy the target. You know what I mean to say. This is used by the enemy, army people. ठीक है? तो यहाँ पे देखिए, जब हम यहाँ से shell हम fire करें बेटा, to destroy the target, the shell has the motion like this. इस तरह से जाएगा वो shell. It has to reach the target. But because of like जैसा कि मैं आपको एक चीज बताता हूँ, like you might have not observed this part. आप देख लिए होंगे कि भाई like you might have observed in TV कि भाई when they pin up that bomb and they throw it, that bomb reach the target and after that it explodes. Are you getting my point? What the example? when they pin up the bomb, पिन निकालते ना बेटा बॉम्ब से, निकाल के जब when they throw that bomb to the particular target, that bomb will reach the target and it explodes. Where it happens? कहां पे होता है ये? सिर्फ और सिर्फ क्या बोलना चाहिए, टीवी या मूवी की दुनिया में होता है, ठीक है. बॉम्ब डज नॉट नो दैट इट हैज रीच द टारगेट. आप चलो वहां पे गिर गए, अब फुटना है, चलो देख लिया तरफ, हाँ टारगेट आ गया, हाँ आ गया, अब एक्सप्लोड हो जाएंगे. ऐसा तो नहीं होता ना बेटा. बॉम्ब डज नॉट नो वेदर इट हैज रीच द टारगेट और नॉट. इट हैपेंस ओनली इन मूवीज. Sometimes what happens, if suppose some delay is there, the bomb explodes in the hands of that particular person who is trying to throw. Sometimes it explodes in the mid-air itself, and sometimes it reaches the target. Bomb does not know whether it has reached the target or not. So that, as an example, what I'm giving here is when the cannon, like a bomb, just imagine this is a bomb only. So when it is thrown to destroy the target, क्या हो रहा है यहाँ पे देखिए अच्छे से बेटे. Sometimes या मिड एयर में ही ये जो बॉम्ब है, और क्या बोलना चाहिए बेटा, शेल है, इट इज एक्सप्लोडिंग. यहीं पे एक्सप्लोड हो गया ये. आर यू गेटिंग माय पॉइंट? यहीं पे एक्सप्लोड हो गया. सो व्हाट हैपेंस, व्हेन इट एक्सप्लोड्स इन द मिड एयर, डिफरेंट पार्टिकल्स विल बी मूविंग इन डिफरेंट डायरेक्शंस. डिफरेंट पार्टिकल्स पूरे डिफरेंट डायरेक्शंस में चले जाएंगे बेटा, एयर में पूरे डिस्पर्स्ड हो जाएंगे एयर में. लेकिन the center of mass, whatever the center of mass is there, that center of mass will be reaching the target. इस तरह से reach होगा. So what is this? Can I say that the motion, previously the motion was a parabolic path. After explosion also, the motion of the center of mass is a parabolic path. The motion is not getting changed. The position is not getting changed. The motion is not getting changed. So internal forces has no effect on the position, has no effect on the motion of the center of mass. I hope it is clear. मिड एयर में एक्सप्लोड होने के बाद भी बेटा उसका जो सेंटर ऑफ मास होगा, whatever the center of mass is there, it is going to reach, the center of mass is going to reach the target. I hope it is clear. So these two examples you take down for the third characteristic. अब एरोप्लेन कोई को ब्लास्ट कर रहे बेटा, मैं जो एग्जाम्पल दे रहा हूँ वो ले लो, बस खत्म होगी बात. आप लोग एरोप्लेन की बात करेंगे, फिर एरोप्लेन में पूरे क्रूज की बात करेंगे, फिर पूरा वो लोग कहाँ जाते हैं सर, वो सब अपने को डिस्कस करना नहीं है. हाँ, जब आप कॉलेज को आ जाएंगे ना, इंशाल्लाह जितना आप डिस्कशन करना चाह रहे हैं उससे ज्यादा मैं डिस्कस करूंगा, ठीक है. दिस इज द पोजिशन ऑफ द पोजिशन. अच्छा ये बोल रहे बेटे आप, देखिए दिस इज द क्रैकर इज देयर. दिस क्रैकर को हम एक्सप्लोड करा रहे हैं. So the center of mass will be there here, no? The center of mass will be here only. Different particles will be moving in different directions. Center of mass वहां से अपनी जगह पे से नहीं हटता बेटा, ठीक है. क्यों? Because the one property is there, one characteristic है कि भाई the position of the center of mass does not change. ऐसा नहीं है बेटा, दिमाग में ये चीज मत लाइए कि भाई ये प्रॉपर्टी रहने से ये हो रहा. Center of mass does not know all the properties which they have to obey, right? ये होने से ये हो रहा नहीं, ये होने से हम ये लिख रहे हैं. Try to understand. This is happening, that's why we are writing this. We are writing this, that's why this is happening. No, that is not the situation. ठीक है. eight seven two. I repeat once again, 872. बेटा यहाँ पे हम कोई गेम्स नहीं खेल रहे हैं, ठीक है. आप मैसेज डिलीट कर लीजिए, बट आई एम हैविंग वन ऐप विच इज देयर फॉर मी टू हेल्प विच मैसेज वाज डिलीटेड, ठीक है. तो आप मैसेज डिलीट कर लीजिए, कुछ भी करिए, कोई इफेक्ट होने वाला नहीं है. तो 872, आई रिपीट वंस अगेन 872. यहाँ पे मैं लिख रहा हूँ, देखिए बेटा मेरे रिमेंबर्स के लिए ये 872 ना बेटा, आप डाउट्स मत भेजिए मेरे. व्हेन आई एम एक्सप्लेन यू समथिंग, और आप जो है ना गेम्स की बात कर रहे हैं यहाँ पे, सर ये पबजी में ऐसा होता, नॉलेज होना, ये होना वो ना, को भाई हमारे को वी डोंट रिक्वायर द नॉलेज ऑफ द गेम्स. बिकॉज आप जो है ना नीट में जाके पबजी खेलने वाले नहीं है, वहां पे एग्जाम लिखने वाले हैं, नहीं तो अपन एग्जामिनेशन पॉइंट ऑफ व्यू से बात करेंगे। हाँ, कॉलेज को आ जाइए आप नहीं पढ़े तो यहाँ पे मैं अच्छे से अच्छा आपको पबजी खिलाता हूँ यहाँ पे, ठीक है ना बेटे। 872 बेटा, फोर्थ प्रॉपर्टी लिखिए, चलिए। 8 फोर्थ प्रॉपर्टी लिखिए बेटा, फोर्थ वन। द सम ऑफ द मोमेंट्स of masses, the sum of the moments of masses of the particles, the sum of the moments of the masses of the particles the sum of the moments of the masses of the system of particles about the center of mass the sum of the moments of masses of the particles about the center of mass is zero, is zero. This is the fourth property beta. Ye fourth property I'm not explaining, but this property I have given. But this property I'm going to explain when I discuss one theorem, that is parallel axis theorem. Parallel axis theorem में we are going to discuss this property, but this property is there, that's why I have given you. तो आप just इसको ऐसे ही रखिए, ठीक है। And what the thing I am receiving कि भाई सर पहले समझने में मुश्किल हो रही कहते, ठीक है, प्लीज गो स्लो। अभी कितना स्लो जाऊं बेटा मैं, मेरे हिसाब से नहीं। एक काम करिए आप, once I start the long term, no long term, you know what is this long term course, वो कोर्स में कभी आप मेरा लेक्चर देखिए बेटा, वहां तो आप इस हिसाब से बोल रहे हैं इतना स्लो जा रहा हूं तो और स्लो जाओ बोल रहे हैं। वहां पे लॉन्ग टर्म में क्या होता मालूम बेटा, आई डोंट गिव इवन टाइम टू कॉपी ऑल्सो, बिकॉज फॉर लॉन्ग टर्म वी नीड टू कंप्लीट फर्स्ट ईयर सिलेबस, सेकेंड ईयर सिलेबस ओनली इन 1 year। आर यू गेटिंग माय पॉइंट? तो अब आप ट्राई टू मेक यूर सेल्फ फास्ट। कितना स्लो जाऊं मैं बताइए, मैं बता रहा हूँ ना बेटा, मैं ना चाहते हुए भी इतना स्लो जा रहा हूँ कि अभी जितने टॉपिक्स मेरे को कवर करना है फिर नेक्स्ट डे फिर लेकर आके कवर कराना है पड़ा मेरे को। ट्राई टू अंडरस्टैंड, आई कैन नॉट गो बियॉन्ड दिस, इसके आगे मैं नहीं जा सकता बेटा। हाँ, फास्ट जाने की कोशिश करूंगा लेकिन अब स्लो तो नहीं हो सकता, सॉरी टू से। आप अपना थोड़ा सा स्पीड बढ़ा लीजिए। इंशाल्लाह वी मीट इन द नेक्स्ट क्लास। थैंक यू, जज़ाकल्लाह।